So in Lewis theory, we're going to represent valence electrons as dots. And so one of the things I like about Lewis theory is we can actually draw pictures and feel like we're seeing what's going on. So for Lewis theory, we're just going to use Lewis theory for the main group elements, and we're going to stick to the stuff that's pretty predictable. Lewis theory does not work for everything, but it's really useful for some things. And so what we do is for the main group elements, we represent them as the element symbol surrounded with a number of dots equal to the valence electrons that they have. And the result is called a Lewis structure or a dot structure. And sometimes they're also called electron dot structures. So if you've had chemistry before, you may have heard different names for them. The number of valence electrons for any main group element is equal to the group number of the element. And that's something we just went over, looked at the electron configurations and why they are that way. So let's look at oxygen. So the electron configuration for oxygen is what? Oxygen has 8 electrons, right? So it's going to be 1s2, 2s2, 2p4. And we can do that by looking at the periodic table. We see that oxygen is in period 2, and it's in the 4th box of the p block, right? So that's where we get the 2p4 at the end there. So this is the electron configuration for oxygen. These are the valence electrons, right? 6 valence electrons for oxygen. So when we write a Lewis structure for oxygen, we're going to have, oops, not that. We're going to have the element symbol, and then we're going to have dots, 6 dots. And so 1, 2, 3, 4, 5, 6. That's the Lewis symbol for oxygen. We're only looking at the valence electrons, because those are the ones that are involved in bonding. The core electrons just stay there on the inside and don't do anything. They're like couch potatoes. Any questions?
For core, there's only 2 core electrons?
There's only 2 core electrons for oxygen. Yeah. And the smallest elements, hydrogen and helium, they don't really have any core electrons because their only electrons are valence electrons. Yes?
Is there a specific way to dot?
Is there a specific way? That's a good question. I think it comes up in the slides later, but we can talk about it now. What we usually do is we place these dots on the top, the bottom, the right, and the left, and we do them, we'll pair them up. And I think one of the reasons for doing this is because you can tell by looking at them how many spots there are. If you put them in a circle, like if you have oxygen and you just do them kind of randomly, 1, 2, 3, 4, 5, 6, that wasn't very random. It's harder to look at them. We want to avoid having to count dots. So that's one reason. The other reason is that when electrons form bonds, they do so in pairs. And so it is significant that they have pairs. So, you know, like on a lab where you're drawing stuff like this, I wouldn't necessarily count this as wrong, but it's not the best. This one over here is better. Now, is there any significance to being the pair on the top and the pair on the right? No. I could do it like this and have the pair over here and the pair here.
That's kind of what I meant.
Yeah. And so that's fine, because what's the difference? Well, it's just the one's twisted around.
Okay, I just didn't know if
Yeah.
there was a certain.
So if we can, we're going to draw them individually, not paired up, and then we'll pair them up. So I usually go 1, 2, 3, 4, the 4 positions around, and then double up where needed, a little bit like with the orbitals. Any other questions? So each dot represents 1 valence electron. We're going to place the dots around the element symbol with a maximum of 2 per side. So top, bottom, right, and left. The exact location of the dots is not critical, but we put them in individually first and then pair them up. And that is especially important with mastering chemistry. Okay, mastering chemistry is picky about that. And we find that atoms with 8 valence electrons are particularly stable, and that's called an octet. Just like, a quartet of people singing is 4 people, and an octet is 8 people, right? So 8 valence electrons is an octet. And the noble gases are the ones with octets, right? So mastering chemistry would not like it if you did that. It would count that wrong. So just to be aware of that. So let's do some more here. And I put the symbols on here. Write the Lewis structures for the first 10 elements. Well, how many electrons does hydrogen have? It only has 1. So that's going to have 1 dot. Maybe my dots need to be a little smaller. 1 dot. Does it matter where I put it? Top, bottom, right, or left? No, it doesn't. Helium. 2. Lithium has 3. Beryllium has 4. Boron, I'm sorry, wait a minute. I got carried away. Lithium has 1. It has 3 electrons, it only has 1 valence electron. Brain fart. Okay, beryllium has 2. Boron has 3. Carbon has how many valence electrons? 4. So we're going to put 4 dots. Nitrogen has 5 valence electrons. So now we're going to have 1 on each side, and then somebody has to be paired up. You can put the pair anywhere, top, bottom, right, or left, doesn't matter. Here's oxygen, 1, 2, 3, 4, 5, 6. Fluorine has 7, 1, 2, 3, 4, 5, 6, 7. I just anticipated. Neon has 8. This is what everybody's trying to get to. They want 8 electrons. Everybody except hydrogen and helium. These guys are little. They can't handle 8 electrons. But helium has a full valence shell. And so 2 is good enough for these little guys. Any questions?
So because helium has to be considered stable?
Yeah, helium is very unreactive because its valence shell is full. It just doesn't fit the pattern of 8 because it's too small. So it does 2 instead. So we say it has a duet. So in Lewis theory, when we look at bonds, a chemical bond involves the sharing or transfer of electrons. And we see that atoms do that in a way to obtain stable electron configurations for the bonding atoms. So in an ionic bond, we have electrons being transferred. The metal says, here, I'll give you this electron. The nonmetal says, oh, great, thanks, and takes it. Now we have a positive charge and a negative charge, and they are attracted, and that is ionic bonding. Covalent, co means share. Valent refers to valence electrons. A covalent bond is 2 atoms sharing their valence electrons. And they're going to do this in a way to get 8 electrons. And so what we call the octet rule is that in chemical bonding, atoms transfer or share electrons to obtain outer shells with 8 electrons. And these little guys, hydrogen, also lithium and beryllium, they follow the duet rule. They're just trying to get 2. We don't need to talk about helium following a rule because helium doesn't make any compounds. Helium's all cool with himself and he just doesn't interact with anybody. He won't share his electrons with anybody. So let's see how this works. So let's write Lewis structures for magnesium and sulfur. And first of all, I'm going to peek ahead. So magnesium and sulfur. So the symbol for magnesium is Mg. And how many valence electrons does magnesium have? 2. It's in group 2 of the periodic table. It's got 2 valence electrons. And sulfur is S. And how many valence electrons does sulfur have? 6. 1, 2, 3, 4, 5, 6. Now, magnesium and sulfur will form a compound. What kind of a compound? Covalent or ionic? Ionic, because we have a metal and a nonmetal. Metals and nonmetals don't share together. The metal is generous and gives. It just transfers. Oh, you can have the electrons. And so what we're going to see is that magnesium and sulfur are going to react in a way that magnesium is going to give his valence electrons to the sulfur, and in doing so, they will both become ions, and then they'll be attracted by their opposite charges.